Alright, this lesson is dividing polynomials. There's two methods to dividing polynomials. First one is long division, second is synthetic division. I will be showing you examples for both today. So kind of stay focused at this lesson to make sure we grasp the content that's being taught out. The first problem says, dividing a polynomial by a monomial, meaning by one term. Make the monomial the denominator, which is the bottom of a fraction of each term. So all I'm going to do is just take 10x cubed and divide that by 2x. Then plus a 12x cubed, x squared, and also divide it by 2x. Keep the pattern going. And now we reduce. This x can cancel with this to give me a 2 here. 2 can cancel with a 10 to give me a 5. So that leaves me with 5x squared. Then the next one, x with this just leaves me with 1 here. 2 with a 12 gives me a 6. So I get plus 6x. X and x cancel, so I'm left with 3 halves. And here the 2 and the 4 reduce to give me a 2 on top. So I'm left with plus 2 over x. And that's our solution. So let's look into a basic example of long division. And I'm going to look at this example here. 277 divided by 12, or 277 over 12. And the first thing I want to do in doing long division is figure out that first step of, can 12 go into 2? No. So then I'm going to go to 12 into 27. So I say 12 times what equals 27. And there's no exact number, but the closest one is 2. Because now 12 times 2 is 24. So I subtract. I get 3. You bring down the next number. So now I go to this step again. 12 times what equals 37. And I think it's 3, because 3 times 12 makes 36. And I have a remainder of 1. So the remainder of 1 just becomes, the answer is 23, and the 1 goes above this number here. So my answer is 23 and 1/12. So we have to apply this into an example like this over here. And here's how it's going to work. I'm always going to care about this first term first. So I look at the problem and I ask myself, x times what gives me x cubed? Because x cubed is my first term. So x times what gives me x cubed, and the answer to that is x squared. So on top, I write x squared. And it goes over the second term because I have 2 terms here, so kind of skip the first one and go to the second one. So x squared times x times x plus 2 is x cubed plus 2x squared. So that's what I write here. Minus x cubed plus 2x squared. And don't forget that when you're subtracting, this can become a positive, this becomes a negative, and this becomes a negative. So these will cancel. 7 minus 2 is 5. So I get 5x squared, and I bring down the next term. Then I repeat the process over again. There's the first one. Here's the second one. X times what gives me 5x squared? And the answer is 5x. So take that 5x and I multiply it by this. X plus 2. That gives me an answer of 5x squared plus 10x. So what I have my answer of comes down here. I'm going to subtract again. 5x squared plus 10x. Don't forget change signs. And I add down, these cancel. 3 minus 10 is a negative 7x. Bring down this 4. I go one more time. X times what equals a negative 7x. My answer is negative 7, so I take the negative 7 and I multiply it to x plus 2. And I get negative 7x minus 14. I subtract that. Change signs. Add down, these cancel, and I get 18. One little mistake I've been making is I've been forgetting to add these numbers on top. Let's add them in very quickly. This would be plus 5x and minus 7. And I have a remainder of 18. So my answer is x squared plus 5x minus 7 plus 18 over x plus 2. I'm going to skip the remainder theorem for now. I'm going to look at this example here. And it says if f of a equals 6a cubed minus 23a squared plus 29a minus 12, and g of a equals 2a minus 3, find f of a divided by g of a. And so it kind of set the problem up for me. So I begin again. Let's kind of give myself some room over here. 2a, look for here and here first. So 2a times what equals 6a cubed? My answer is 3a squared. 3a squared goes here. 3a squared times 2a minus 3 equals 6a cubed minus 9a squared. Subtract. Change signs. Cancel, cancel. Negative 23 plus 9 is a negative 14a squared. Bring down the 29a. Next one. 2a times what equals a negative 14a squared? My answer is a negative 7a. Negative 7a times 2a minus 3 equals negative 14a squared plus 21a. Subtract, change signs. You get 8a here. Bring down the negative 12. We ask ourselves one last time. 2a times what gives me 8a? My answer is 4. So 4 times 2a minus 3 equals 8a minus 12. Kind of reminds me of the one that we have here, right? So subtract 8a minus 12. Anything subtracted by itself just cancels. So we're left with 0. Which means my answer is, and once again I forgot to write them all up here. My answer is 3a squared minus 7a plus 4. Since this is 0, that means that there is no remainder. Then the factor theorem. A polynomial has a factor of x minus k if and only if f of k equals 0. Applying the remainder theorem above, this means that if x minus k is a factor, the remainder must be 0 when we divide it. So, state that the given binomial is a factor of the given polynomial. Remainder of 0. If it has a remainder of 0, then it is a factor. So, h cubed minus 27 divided by h minus 3. Fill in zeros with missing terms. Notice how I go from h cubed straight to a constant. I'm missing the h squared and the h. So I'm going to fill those in by just putting zeros. And now I solve it the same way. First one, h times what equals h cubed. My answer is h squared. That goes here. H squared times h minus 3 equals h cubed minus 3h squared. Change signs. Add down. These cancel. You get 0 plus 3 is 3h squared. Bring down the 0h. We do this again. H times what equals 3h squared. My answer is 3h. That goes here. 3h times h minus 3 equals 3h squared minus 9h. We subtract. Now when you subtract, you change signs. And I get positive 9h. Bring down the negative 27. Ask myself one last time. H times what equals 9h? My answer is 9, so I get 9. 8 times h minus 3 equals 9h minus 27. So minus 9h minus 27. Opposites cancel. I'm left with the remainder of 0. Therefore, yes, h minus 3 is a factor. And did you recognize this is the difference of cubes pattern that we just learned? So you could have checked this by multiplying. If you multiply those out, you get this and this, then you combine these to give you an answer of this, but without the zeros. You're left with the difference of cubes. Alright, now I want to show a little bit of synthetic division. Okay, for synthetic division, so I'm going to do this problem on the left. Not that one. This problem. And it's already shown for you by long division with an answer of this. I'm going to show you how synthetic division is the same thing. First, we need to use the coefficients of each term. So, first term is x cubed, therefore it is a 1. So I'm going to write a 1 here. 7x squared is 7, so I'm going to leave gap. 3x, so it's a 3, and 4. So those are all the coefficients. Next, we need to find the value, find the x value that makes this piece, so x plus 2, equal to 0. And it's a one-step equation, so you just subtract, so you get that x equals a negative 2. So this is the number I'm going to use for synthetic division. This number goes here, and I put it in a little box. Then I draw a line. First step, bring down your first number. Then I do 1 times the box number, and that goes up here. So 1 times a negative 2 is negative 2. I add down, so 7 minus 2 is 5. I repeat the process, times the negative 2, add it up here, and I get negative 10. Negative 10 plus 3, so you add down, gives me negative 7. Multiply by negative 2, you get 14. 14 plus 4 is 18, and we are done. Now these numbers here are the coefficients of each term. And the coefficients of each term of my solution, but we start with an exponent 1 less because we already divided. So for example, I started here with x cubed, which means this first one is going to be x squared. So 1 in front, but we don't need it, plus 5x minus 7, now this 18 is going to be the remainder, plus 18 over, and I add it to over this, and this is my solution. Notice how this matches this one from up here. If the remainder was 0, we could try to go on and factor the remaining polynomial, but it isn't, so we stop there. One thing to notice is that here we changed signs at every step. But in synthetic division, we changed the sign first. Let's do another example. So in this one here, I have h cubed plus, remember, 0h squared plus 0h minus 27. So my numbers are 1, 0, 0, negative 27, with the opposite of this would be a positive 3 in the box. First step, add down 1. Multiply by 3, because that's the number in the box, and I get 3. 0 plus 3 is 3. Multiply by the number in the box, 3 times 3 is 9. Add down is 9. Multiply by the number in the box. 9 times 3 is 27. 27 minus 27 is 0. Which means I have h squared plus 3h plus 9 plus a 0 over h minus 3. And so this isn't needed because it's a 0. There's your answer. And one last one I'm going to show you is the one on the right. It says if one factor of this is this, if it's a factor, that means I'm going to get an answer of 0. Then divide to find another factor, so which means your answer is just going to be the other factor. So my box is a negative 5. My numbers are 4, 20, negative 9, negative 45. Add down, multiply by the box. Add down, multiply by the box. Add down, multiply by the box, add down. So this is what we wanted. And so my answer is, if this is c cubed, this would be 4c squared plus 0c minus 9, or 4c squared minus 9. And we know that this times what we started with would give me an answer of this up top.